What's up, everybody? This is Coach Sharf. Welcome back to my Algebra 2 notes videos. And today we are doing notes on real-world exponential functions. I'm recording this in the 2022, 2021, 2022 school year on March 17th, actually. Thought I did this video last year, but I just did the examples from the worksheets that go with this assignment. So I didn't actually get these notes down. So I figured I would pop this video out. So I'm going to pull up active board and we'll get started. So I've talked about it in class. These real world exponential growth and decay problems, to me, are the most, it's in the name, the most real world thing y'all are going to do. And y'all can, again, it hadn't really happened a lot this year, but when y'all say, when am I going to use this in the real world? Well, you use a lot of this stuff in the real world directly, and some of it even affects you indirectly. If you're investing money, you calculate the interest with exponential growth. When you borrow money, you calculate the interest that you owe with exponential growth. When your car loses value over time, or if you bought a PS2 and you're still hanging on to that, and the PS5's out now. The value of your PS2 going down over time, before it turns into I guess an antique maybe and starts going back up. But so we'll say your PS3. Things like that. Bacterial growth. Again, we're 2 years into it's a virus, but we're 2 years now into there's a bacteria. I don't know if it's a bacteria virus, but COVID. We're 2 years into COVID. So I'm sure you could look up real world exponential growth models on the spread of COVID. So it probably started slowly and then kind of started going up and then really took off. I feel like each of the new variants, so Delta kind of took off more quickly. Omicron even took off more quickly in terms of how it spread and the number of people that got it. So those are just some examples. I'll talk about some more as we go through this as well. So for this note slide, let me move my head up. We have our growth formula and decay formula. If you got the notes when we did them from the book or in the last note section, I had y equals a, 1 plus r to the t, y equals a, 1 minus r to the t. So just switch them out with A and P because this is more what we use. Again, we usually talk about this when we're investing money. Of course, we use other things as well, but usually money. So P is our initial amount. The P stands for principal. So when you borrow money or you invest money, the original amount is what's called your principal. A is the final amount. So whatever the amount of money in your account at the end of your investment, amount of money you wind up paying on a car loan or mortgage. If you talk population growth, after the population grew at 3% for 10 years, what's the final population? R is rate of growth or decay, and T is amount of time. Here we're just comparing it to our original exponential function model, showing how everything lines up. So I'll take a second, get this down. I'll give about 5 seconds here. Y'all can pause and write it down. Then I'm going to go ahead and move to the next slide and jump into the problems. All right. So our first example is a growth example. And I'm telling you it is a growth example, but there's going to be some things we have to look for when we're talking regular growth and decay problems. The population of Covington is currently 14,000 people. If the population is growing at 3% per year, what will the population be in 10 years? So when we're talking regular growth and decay problems, there's really 5 things that we got to identify. 4 we'll be able to. The one we can't is the 5th thing we're looking for. The first should always be whether it's growth or decay. So we got to know whether we're using 1 plus R or 1 minus R. There should be a keyword in your problem somewhere. In this case, it's grow. Okay, thought I had on a different color. It's grown. So grows, increases, goes up by. Shrinks, decreases, goes down by, would be ones for decay. So growing, so we know it's a growth, so it's going to be the 1 plus R. And we got to look through. So none of the numbers you get in any of these problems are going to be unnecessary. So everything you get should have some significance. Okay. So 14,000 is going to be our P, our initial population. 3% is going to be our rate of growth. 10 is going to be our amount of time. So we're looking for A, what will the population be in 10 years? So that's what we're looking for. We're using 1 plus R to the T power. P is 14,000. R is 3%. We know what we have to do when we have a percentage. And I'm going to show y'all the wrong answer we'll get if we don't do what we're supposed to do correctly. I'll get to that in a second. T is 10. So if I was going to fill these in, 14,000. 1 plus 3 to the 10th power. Okay. I'm actually going to cut out one of these equal signs here just for this example, because what I'm going to do when I'm calculating these is I'm going to show y'all how to punch it in on both this calculator and iPhone. Okay. So that's what I'm going to do with those. This one, though, it's so big, I'm just going to use the computer calculator, and this is what's going to be incorrect anyway. So 3%, when I say this is 3, what this is actually saying is 1 plus 3 is 4. So it's not 4%, it's 400%, which means your population is quadrupling every year for 10 years. So that's really what that's saying. So if I do 1 plus 3, that's 4. I raise that, hit the XY button over there to the 10th power. It's 1,048,576. And then I multiply that by 14,000. So that means the 1 million number means my population is going to be 1,048,576 times larger than it was at the beginning, which gives me 14,680,064,000. Okay. I just clicked on it. It says screen sharing. I think this thing's better about it now, but let me make sure. Yeah, it still says I'm sharing active. Okay. So let me actually show the calculator. I always forget to do that when I start this first. All right. I did 1 plus 3 is 4. 4 to the 10th power, 1,048,576 times 14,000. You get 14 billion. Okay. So that's definitely probably not correct. We're not going to go from 14,000 to 14 billion people in 10 years. So logically, it's not correct. Also, if you think about the planet, there's only 7.5 billion people on the planet now. So there's not going to be 14 plus billion people in Covington in 10 years. Okay. So that's incorrect. Well, it's incorrect because of this 3. So what we have to do is, since it's a percentage, we got to move that decimal spot 2 spots to the left. Okay. I'm going to go ahead and say it now because it's going to come up later. Doesn't matter if it's 3%. Doesn't matter if it's 12%. So I get 0.12. Doesn't matter if it's 4.25%. Doesn't matter if my percentage has a decimal already in it. I still got to move it 2 spots to the left. All right. All right, so let's do this correctly. 14,000 parentheses 1 plus 0.03 to the 10th power. So we're going to start in your scientific calculator. Again, I'm going to use the blue ones that the school has. Okay. If I'm punching this in here, it's going to look basically the same. 1 plus 0.03 to get my exponent. It's that caret button. Okay, it's that big arrow above x squared. I'm going to stop sharing and show the calculator bigger because I realized when I was doing it last year, I'm way up here in the corner. I'm pointing at the corner. Y'all can't see me pointing at the corner. There we go. I'm way up here in the corner. It's kind of small. So I'll stop sharing the screen when I'm punching it in the calculator. If you're using your iPhone, can't type in a whole equation at once in your iPhone. You got to go step by step. So you're going to have to do 1 plus 0.03. You hit equals, and that's going to give you, I'm going to do it in purple to give you the number iPhone gives you, 1.03. Then you're going to have to turn it sideways, hit the X to the Y button. 10 equals, which is going to give you 1.343916. So I'll just say 1.344. You want to keep the whole decimal on your calculator. I'm just rounding for the sake of easiness here. Then times, this is multiplying, not X, times 14,000 equals our answer. Okay. So let me show you on, all right, let me stop sharing now. I'll show you on both calculators. Regular calculator. Type in 14,000. I'll go ahead and type it in. Parentheses. 1 plus 0.03. Close parentheses. That big arrow we call caret. 10. I'll go ahead and hit equals. Get 18,814.83. Around that to 2 decimal spots. iPhone. On the iPhone. All right, so we'll start with 1. We'll do 1 plus 0.03 because I think that's what I did on there. So one plus, we're talking about an NCAA tournament. The NCAA tournament started today. I got one of my first games wrong. If y'all saw those iPhone messages. 1 plus 0.03 equals 1.03. Then we're going to hit the X to the Y button. 10 equals, here's my 1.34391, so on, so on, so on, so on, times 14,000 equals 18,814.82. So we got the same answer, 18,814.83. So that's what I'm initially going to write, but so either way we did it, we got this, but we're talking about people. Okay. We're talking about people. So I'm not going to have a fraction of a person when I'm counting population. So this is what I'm writing right now, but I'm not going to have a fraction of a person when I'm counting population. So we're just going to go ahead and round up and make it 18,815. Just go ahead and round up and make it 18,815. Okay. So we started at 14,000. Now I have 18,815. So how does this tie into the real world? Well, I just realized I'm not sharing the screen. I've got to go back and share it. That's why I don't like Zoom sometimes. All right, so there's the 18,814. We rounded up to 18,815. So, what does this mean context-wise? Well, that 14,000 was within the actual city limits of Covington. If y'all see those signs driving around town, if you live out by Alcovey or in the eastern part of the county, but your address is still Covington, it's not Mansfield or New Bern or whatever. You have a Covington address, but you're not within the defined city limits. Okay. The population for when I looked it up for all of Newton County was 111,000 people. 111,000 people growing at 3% per year would go up to 149,000 and some change in 10 years. So an increase of 38,000 in 10 years, in a decade. So even though population, growing population, you're gonna say, Coach Scharf, what effect does that directly have on me? Well, the direct effect, honestly, is going to be that If we got, I mean, people moving to the area, there's going to have to be, I think my collar's messed up. There we go. Sorry. There's going to have to be more roads built for neighborhoods and things like that, more sewer pipes and water pipes, more schools built. Because there's, you know, all 38,000 of those people probably aren't going to be adults. So more schools built. And so when the government has to build all these things, how do they get that money? Taxes. Who pays taxes? We do. Might be property taxes. None of y'all have to worry about right now, but it could also just be, you know, an extra 1% on sales tax. So everything you buy in Newton County, you're going to pay an extra penny for every dollar, something like that. There's also indirect benefits. If there's more people moving in, there's going to be more restaurants, more grocery stores, more houses being built. So you might be able to, you know, move into a new house, depending on the price or whatever. So possibly more entertainment options. Maybe we can actually get our own movie theater. Instead of having to go to Conyers, maybe we can get like a putt-putt course or something. I don't know. But there's indirect effects on you as well. All right, next slide. So this one, I did not write what kind of a problem it was. We have to read the problem to get it from context. We buy a brand new car for $25,000. It loses 15% value every year. How much will the car be worth in 5 years? Gotta work for our keyword, loses. So this is going to be decay. So we're going to have to use the P1 minus R to the T power. 25,000 is P, 15% is R, T is 5. So I've got it set up, our 15%. We still got to move the decimal 2 spots to the left to get 0.15. So I've got 25,000, 1.15 for R. T is 5. Okay. So when I go to fill this in, 25,000, parentheses 1 minus 0.15 to the 5th power. Again, your iPhone calculator, pretty straightforward. 1 minus 0.15, caret 5. iPhone, 1 minus 0.15 equals, I think that purple shows up, 0.85. I hit, turn it sideways, hit X, it's supposed to be white, X to the Y, 5 equals, no, I'm hitting 5. I'm typing 5, so that's still white. I'm sorry. X to the Y, 5 equals, gives me 0.4437, which again is rounded. And then I would multiply that. Again, this is multiply. 25,000 equals. Okay. So this is how it's set up. Again, when I'm doing these now, if you have your own scientific calculator at home, or you have one from the school, or even the new silver Casio ones from the school, they're pretty similar. So when you're doing these notes, whatever calculator you're going to be using, you could just, so if you're going to be using this, you could just do the calculator. If you don't have a calculator at phone and need to know how to punch it into your iPhone, you can write down the iPhone one. Okay. But I'm showing both to cover all bases. Okay. So again, I'm going to drop this off the screen. So pause it real quick if you need to finish writing it. I'm going to drop it off the screen though, so I can be full screen and show this. So pause it now if you need to. All right. Dropping it off the screen. So 25,000. Already got it typed in. Parentheses. 1 minus, you gotta make sure you hit the correct minus, actually subtraction, not the negative, make the number negative 1 down there. It's gonna give you syntax error. 0.15, close parentheses to the 5th power. I'll come back and hit equals on that in a sec. So we see that we got the same number on your iPhone. One minus 0.15 equals 0.85. Find the x to the y button. You got x squared, x cubed, x to the y. 5 equals times 25,000. $11,092.63. Okay. If I come back and do it on here, $11,092.63. So that is our decay. And I think what I'm actually going to do for the sake of time, because I need to get home, I'm going to do this one. We're going to, then we got to do some compound interest ones as well, but I'll make that another video. And honestly, I'll probably wait to do that one until tomorrow, real time. But I'll go ahead and record this and try to get it uploaded to YouTube and at least get this in at some point tonight. So it will be into your canvas. So yeah, so either way I do it, I don't know what's going to show up. Is this going to show up? Well, it's showing up on here and it's not being projected. So I think so. $11,092.63. This is money. It's value. So it's not money being invested, but it's still value. So I can leave the decimal on there. All right. So again, what does this mean big picture? What does this mean big picture? Well, actually, I talk about it after I do the first compounding interest. Okay, so I'll refer back to it in the next video, but we need to remember that this is what our car was worth after 5 years, because we're going to compare it. We're going to take out a loan to buy the car, and we're going to talk about it. Okay, so I'm going to go ahead and cut this video off now. We're going to talk about compound interest in the next video. So make sure that you go find that and watch that. So until that video, I'll see you guys later.